Hey, hello, how are you doing? What we are going to do, we are going to prepare you for your test. The test number 3, you know that the test number 3 is going to be on Tuesday. So I just posted a practice test for you. This practice test would be mainly the things that we did for the test 3 and plus the power series. I wanted to give you more from the power series, but I just give you the preliminary definition because it's a very important one. So in the case of the power series, only you are going to find the radius of convergence and the interval of convergence. So most of the problem are similar to the quiz number 3 that you did. So what I'm going to do, I'm going to do the part with the power series for you, so that give you, in advance more information. And the rest of the problems are the same as we did before. So I may again post another recording for you going over the other problems too. Okay. So as you know that the test is going to be on Zoom. It's going to be on Tuesday at 6:30. I just, this link is going to be the same link, but I posted the one on the Canvas so that you get it. So at 6:30, you have to log on, as you know that, as we did it before. I have a class, but I try to be on time, but it doesn't matter even I was not available, so you can start your tests because you will see that 6:30 on Canvas, but I'll be fine. I may be late, just 5 or 10 minutes, but I'll let you know. You must log on time, okay? If you, the meeting would be close in after, we start the exam. So otherwise you cannot come to the meeting if you are going to be late. Just make sure you're going to be on time. As usual, we give you 11 questions and you can answer 10 questions, similar to the one that we did on the quiz and the practice one. So make sure that you are going to be on time. This is going to be our last test before the final, and you know that you can drop your lowest test. So the test 1, 2, 3, and then we are going to have the quiz 4, and after that quiz 4, we are going to have the final. Okay, so just make sure that you are going to be, everything would be fine to get this last test, which is going to be mostly, it is all serious. Okay, so Tuesday 6:30, and I'll check your quiz that you did, and then I post the result for you before the test so that you see if you have changed your method of solution or anything wrong. I let you know. So I go to this practice one and I focus on the power series because the power series is going to be the things that we're going to cover for the final. Okay, so let's go to that practice one, and I do at this time. I'm going to do that problem. This is the last problem that we have, is regarding the power series. So we give you 2 questions on the power series. You're going to find the radius of convergence and the interval of convergence. When we talk about it, we can use the ratio test to take care of it. Okay, so there are going to be 2 types of series, power series. It's going to be power series in terms of the variable x, and we said it's going to be around 0, and there is going to be another power series around any given points. So be prepared for it. You have quite a lot over here to practice. Okay, so that's going to be number 4 on the practice test that I posted for you. So this is going to be the one. It's going to be your main job. I wanted to add another section for this test, but then I changed my mind because I don't want to rush it. So that when you are going to do the test, then we go to check the different properties of the power series. So we have enough time to do it. So this is going to be your practice. Okay, practice test number 3. I'm going to focus on problem number 4, which is a big one. So we are going to be given 2 problems on the test from this one over here, 2 or 3 problems. So what is this example you want to find? Okay, you are going to find find the radius. Okay, find the radius and interval of convergence. Interval of convergence. Interval of convergence of each power series. Each power series. We're going to apply the ratio test all the time. Okay, so this is it. We take the first one. The first one, this is going to be our power series. It's a sigma of -1, -1 to the n minus 1. Then we have x minus 5 to the n, and we have the n 5 to the n, and n from 1 to infinity. 1 to infinity. Okay, for all these problems, we are going to use the ratio test. Remember, the ratio test is this one. You take the limit of, in this case, you go with the absolute value because you want to make sure that the variable x is positive, because the ratio test can be used only for the positive numbers. So this is going to be the ratio of an plus 1 over an. You find this one. When it goes to infinity, if you find it and you call it L, I just remind you. We know that if L is less than 1, the series converges. The series converges. Otherwise, it diverges. Okay, and if L is bigger than 1, the series diverges. Okay, that is going to be diverges. And if L is equal to 1, we don't know. We have to check it. So that's all you are going to do for us. But since you have the x, you are going to get these ideas. You put the condition on x so that you will get L less than 1 to get it convergent, and the condition on x otherwise to get it divergent. Okay, so this is going to be our 2. So there you are. And this is going to be all your an. As we talk about it the other night, we can simplify it. You see, this is it. You go with the limit of the absolute value of an plus 1, an, when it goes to infinity. You can write it if you like, but as I talked about it the other day, you see this is x minus 5. That would be x minus 5 to the n plus 1 divided by x minus 5 to the n. When you simplify it, the leftover is x minus 5. And since this limit depends on n, you can put it out. So, you can simplify. You can write it if you like, that's easier. So you can put it out. So you are going to have absolute value of x minus 5 out. Okay, that will help you to summarize it. And this is going to be the limit of n goes to infinity. Is it this -1 to the n or n minus 1? Because you use the absolute value. Because -1 to the n would be either a positive 1 or a negative 1. Since we use the absolute value, that would disappear. Then the leftover is going to be an plus 1. You change the n into the n plus 1. We divide it by an. Okay, again, you can simplify it by write this one. Then you see the leftover on the top is going to be 1. Then I get n plus 1 times it by 5 to the n plus 1. Then I have divided by an, so it's going to be 1 over n 5 to the n. And you don't need any absolute value because everything is positive. Okay, that's a choice. You can write all of them. So you have to simplify. There's going to be absolute value of x minus 5 out. So you focus on this one. So you write the first one, which is going to be 1. It's a division of 2 fractions. So you write the first fraction and you multiply by the reciprocal of the other one. So the reciprocal would be n 5 to the n divided by 1. And you can do this one right at the beginning. Now simplify as much as you can. You see this is 5 to the n, and this is 5 to the n minus 1 plus 1. So the leftover would be 5. So on the top we get n, and on the bottom we get So this is going to be absolute value of x minus 5. Then you have the limit of, on the top, you get only n. On the bottom, you get 5 times n plus 1 when n goes to infinity. You know that you take the limit, just the leading term, if you know it's going to be like x minus 5, limit of n. Okay, it's going to be n. You can pull out this 5 if you like, or just keep it there, it doesn't matter. So it's going to be something like 5n plus 5 when n goes to infinity, and you know that n and n, the degrees are the same, so we shrink it into the n over 5n, so the limit would be 1/5. So it's going to be x minus 5 times 1/5, which is going to be equal to the x minus 5 over 5. Okay, so this is going to be what? I should repeat it again. This is going to be the limit of an plus 1 over an. Okay, this is your L that we got it here. Now we know that if L is less than 1, the series is convergent. So this is your L. So you force it to be less than 1. We say that the series, the power series, you see the power series, according to the ratio test, converges if this result, the absolute value of x minus 5 divided by 5 is going to be less than 1. Okay, so then you solve it for the absolute value, you multiply it. It's going to be x minus 5 less than 5. You see, since your series is in terms of x minus 5, this is R. This is going to be the radius of convergence. So R is equal to the 5. That's a radius of convergence. And you expand this one to get the interval of convergence. We know that the absolute value of x minus 5 less than 5. This means x minus 5 is less than 5. It's going to be between -5 and 5. So R is equal to the 5, and the series converges. The series converges. Okay, converges when x minus 5 is less than 5 and it's greater than -5. Solve for x. So if you solve for x, that give you what? That give you add 5. It's a 5 plus 5. And you add 5 is a -5 plus 5. So that give you what? That give you 0 less than x less than 10. So this means your series so far is convergent in this interval. So the series converges. The series converges on open interval of 0 and 10. But remember the case that when L is equal to 1 means when you get the equality sign. So you have to check it. So when it's a less than 1, it's guaranteed that the series is convergent, but you're not done. Because you may let it to be equal to 1 and you may get a convergent or you may get a divergent. That's a crucial part of all these problems. So you have to check the series for x equal to 0 and check the series for x equal to 10. If they are going to be convergence at 0 or at 10, you have to switch your interval into the close. You may close it at 0, use a bracket, or you may close it at 10. Okay, so you're not done. So check the power series. So you're going to check the power series when x, you know, you do the automatic. I just explained this one for you. When x is equal to the 0 and x equal to 10. Okay, so let's try. X equal to the 0 first. Go back to the original series. Original series. That's it. Replace x by 0. So what are you going to have? So your series would be sigma of -1 to the n minus 1. Okay, now x minus 5, 0, minus 5, everything to the n, divided by n 5 to the n. Simplify it. 0 minus 5 would be negative 5. So it's going to be sigma of negative 1 to the n minus 1. The top would be negative 5. Raise it to the n. The bottom one would be n 5 to the n. We want to simplify it. You see this negative sign here? This negative sign is like negative 1. So it's going to be negative 1 to the n times 5 to the n. So carefully simplify it. So it's going to be sigma of negative 1 to the n minus 1. On the top, we have a negative 1 to the n. And then we have the 5 to the n. Down the bottom, we have the n, 5 to the n. See now 5 to the n and 5 to the n would cancel out. So what's going to be the leftover? The leftover is sigma of negative 1 to the n minus 1, negative 1 to the n, and n. Okay. Now, the thing is going to be, this is negative 1 to the n minus 1, and this is negative 1 to the n. Since you have the common base, you carry the base, you add the exponent. The exponent are n minus 1 and n. If you add them together, it would be n minus 1, and n would be 2n minus 1. So we continue. That gives you sigma of, on the top, if you like, that gives you negative 1 to the 2n minus 1 divided by n. But 2n minus 1 is an odd number because it's like, it's like 1, 3, 5, because if you replace n by 1, that gives you 1. If you replace n by 2, 2 times 2, 4 minus 1 would be 3. So negative 1 to the odd power, that would be negative 1. So this would be the sigma of negative 1 over n. We pull out the negative sign, negative 1 over n. That's it. And this series. Remember, this is harmonic series. Is a p series with p equal to 1, and you know that it's divergent. So is a divergent series. Is a divergent p series. Okay, so this means at x equal to 0, your power series would be divergent. So we cannot use the bracket here. Okay, so this is how we're going to check the endpoints for the 0. Okay, so carefully replace x by 0. This is very important how you do the algebra. 0 minus 5 would be negative 5, negative 5 to the n. So it's like a negative 1 to the n, then 5 to the n. You see, negative 1 to the n, 5 to the n. Then you'll be able to simplify the 5 to the n and the 5 to the n. Then you got to be careful again here. Negative 1 to the n minus 1, negative 1 to the n. So you got the same base, so you add the powers. So n and n would be 2 and 2n minus 1. But 2n minus 1 is an odd number. So a negative to the odd number would be negative. So pull out the negative, so the leftover is a harmonic series. And you know that harmonic series is a divergent series. So we didn't get anything at x equal to 0, okay? But we have to check the 10. So we go back to the power series again. You do it again. It takes time. And you've got to be careful. Everything you understand, everything you learn in this chapter would be used in one of these problems, okay? And it's very good practice, really. That help you to understand everything we covered so far. So we are not done. You have to check x equal to 10. X equal to the 10, again into the power series. Go back to the original one, replace the x by 10. So that was a negative 1 to the n minus 1. We did have x minus 5, so that would be 10 minus 5. 10 minus 5 to the n, and we have the n 5 to the n. Again, simplify. 10 minus 5, this time would be a positive 5. So it's going to be sigma of negative 1 to the n minus 1, and that gives us 5 to the n. And this is n 5 to the n. Now you see the 5 to the n and 5 to the n would cancel out. You get a 1 on the top. What's going to be the leftover? The leftover is sigma of, that's 1. So that gives me -1 to the n minus 1 divided by n from 1 to infinity. You know that. This is alternating harmonic series. The first term is going to be negative, positive 1. 1 minus 1/2 plus 1/3 minus quarter. So you know that. The -1 to the n over n alternating harmonic series is convergent. Because your Pn is 1 over n. The limit is 0 and it's decreasing. And we accept it. So this is going to be a convergent harmonic series or alternating series. So the power series is convergent at 10. Okay, but it's divergent. So what's going to be the conclusion? So the conclusion is that your radius of convergence is 5. Interval of convergence, you see we have the 0 and 10. At 0, it's divergent, parenthesis. At 10, it's convergent, bracket. So that would be the final answer. Okay, this is the way you have to write it down on the test for us. Okay, you have to explain everything. And this would be the final answer. Okay, so that's going to be case 1. The case 1 is more general because your set is going to be x minus 5, x plus 2. It's centered at anything other than 0. If it's going to be centered at 0, that would be a little bit easier to handle. Okay, so we give 1 from each. So that's part A. That was the type 1. Okay, so carefully, this, you just put them nicely together. Make sure don't miss any algebra, and it would be very, very nice practice to get it through. And we have enough here to learn, and it's going to be very similar. So let's check part B. Part B is that kind of type 2 that we talk about it. What's the type 2? You see, we have the sigma r. We have the -1 to the n minus 1 again. But you have power of x. It's easier. X to the n over n squared. So it's like x minus 0 to the n. You see the other one was x minus 5. This is like x minus 0. So the power series is in terms of the powers of the x and from 1 to infinity. Again, go with your ratio test. Okay, so the solution, this is what will happen. So we go with the limit of the absolute value of an plus 1 divided by an. Okay, it goes to infinity. You see we have the x. So that would be x to the n plus 1 divided by x to the n. So x to the n would cancel out. Now the leftover is x. You pull it out. Write down absolute value of x. Then check the leftover. It's going to be limit of n goes to infinity. Since we use the absolute value, this -1 would disappear. So on the top would be 1 over n plus 1 squared. That's an plus 1. And on the bottom, you repeat it with n. Okay, continue. So this is going to be absolute value of x, limit of, write the top fractions, multiply by the reciprocal of the bottom. Reciprocal of the bottom would be n squared over 1. So we are going to have the absolute value of x, and this is going to be the limit of, the top would be n squared, the bottom one would be n plus 1 all squared. N goes to infinity. Again, you see, this would be eventually n squared on the top and the n squared on the bottom. Okay, if you shrink it, if you like, this is the way we think about it. It's going to be equal to the absolute value of x, like the limit of n squared over n squared, because the leading term is n squared, which is 1 again. So that gives absolute value of x times 1. So the result is going to be absolute value of x. Okay, so the limit of an plus 1 over an when n goes to infinity would be absolute value of x. This is your L, or the ratio test. So in this case, this is how we're going to argue. We say that you force it to be less than 1, because if L is less than 1, the series is convergent. So we say that the power series converges if the absolute value of x is going to be less than 1. So this 1 would be the radius. So the radius is 1. And you open it up. Absolute value of x less than 1 means x is between -1 and a +1. So that would be for temporary the interval of convergence. Okay, so R is 1 and the series converges. The series converges when you see that's it, when x is going to be between -1 and +1. Okay, but again you have to check the interval so far would be open interval of a -1 and 1, but you have to check the endpoints. Okay, so we're going to check x equal to -1 and x equal to +1. So if you get the convergence at these points, either one, you use the equality sign, and then your interval would be close at that point. Okay, so go back and check. So this is it. We're checking x equal to the -1. First, go to the original power series. You see this is your original power series. Replace the x by -1. Everything else stays the same. So our series is going to be, this is it. We get the sigma r -1 to the n-1 x is a -1, -1 to the n, divided by what? Divided by n squared. You simplify, you see this is -1 to the n, -1 to the n-1, like the one that we did. When you multiply it, it's going to be -1. On the top, you add these two numbers together, n and n2 and 2n-1. So that gives sigma of -1 to the 2n-1 divided by n squared. But 2n-1 is an odd number because n is 1 to infinity. When you replace n by 1, 2n-1 would be 1. When you replace by n by 2, 4 minus 1 would be 3. So that's odd number. Since it's an odd number, -1 to the n plus 1, again, is going to be -1. So that gives -1 on the top, n squared on the bottom. You pull out the negative sign, so that gives 1 over n squared. You know that it's a power series. That's a P series. That's a P series, P equal to the 2 bigger than 1, so it's convergent. So is a convergent. Just to mention it, convergent power series, we accept that. So it's a convergent P series, sorry, P series. Just for your information, P2 bigger than 1. Okay, so this means the power series is convergent when x is equal to -1. Okay, so we have to check the other side. X equal to 1. So let's just see what would happen at x equal to 1. Again, you go back, we substitute. We substitute x in the original series for x. You see this is it. X equal to 1. So what's going to be the resulted series? So you're going to have a sigma of what? Sigma of -1 to the n-1. This would be 1 to the n over n squared. N from 1 to infinity. At 1 raised to the n would be 1. So this would be unchanged. So that gives a sigma of -1 to the n-1. That would be 1 over n squared. N from 1 to infinity. You know that sigma of -1 to the n minus 1 over n squared is alternating series. Positive, negative, positive, negative, positive, negative. The general term is 1 over n squared, Bn, limit of Bn is 0, and 1 over n squared is decreasing. You know that you need two conditions for the convergence of a alternating series. So this is going to be a convergent alternating series. Alternating series. Okay, because it's positive, -1, positive, -1. Even if you put the absolute value around that, sigma 1 over n squared is a P series. So it's very nice example because you see, so your power series is convergent at x equal to -1 and is also convergent at x equal to 1. So the conclusion is going to be what? So the conclusion for this problem is that the radius of convergence is 1 and the interval of convergence. You see, we did have between -1 and 1, -1 comma 1, but since it's convergent at -1, it must be a bracket. It's also convergent at +1, so this must be bracket. You see, there are 4 possibilities for this. You may have open, open, parentheses both sides, half close, half open. You may have a bracket, -1, the other one, and you may have the bracket both sides. So that's why we check. It depends on the from one series to the other series. The situation would be different. Okay, so it's case 2. So the case 2 is it's going to be just powers of x. You see, it's going to be powers of x, and the other case is going to be it's not power of x. It's going to be something else. Okay, this is the one that we call it is centered at 5, or in terms of the power of x minus 5. And the other one is going to be in terms of the powers of x. Okay, so all the problems are going to be of this category. So that's the part B. So we have another one. We do the part C for you. They are very, very similar operation, but you have to practice to be quick because it takes, it takes times, and you have to explain all the details for us. Let's see what you got for number C. For part C, this is your power series, sigma of, okay, your series is going to be sigma of -1 to the n factorial, x minus 4 to the n, so it's about x minus 4, and divided by 3 to the n, and from 0 to infinity. So this is power series. So it's in terms of the power of x minus 4. Okay, it's not in terms of the x. Okay, let's try. Again, get the ratio test to see what's going on for this one. So we're going to have is a limit of absolute value of an plus 1 over an when it goes to infinity. Again, the series is in terms of x minus 4. So n plus 1 would be x minus 4 to the n plus 1. An would be x minus 4 to the n. X minus 4 to the n would cancel out. You get a 1 factor out. So you have 1 absolute value of x minus 4 as a leftover. Okay, if you write it down, you will see it, but you don't need it. Now this -1 to the n would disappear because we're using absolute value. So the top term is going to be, you just change the n's into the n plus 1. Okay, so you are going to have on the top, the leftover is going to be n. We change it to the n plus 1 factorial. We change this n to the n plus 1, 3 to the n plus 1. Divide by an, you repeat it just as is, n factorial. And that would be 3 to the n. N goes to infinity. That's an plus 1 divided by a. Okay, that x minus 4, I've already take it out. You can write it and simplify it, you get this one. Okay, so write the first fraction, multiply by the reciprocal to simplify it. So this is going to be equal to the x minus 4. As the limit of n goes to infinity. The top would be n plus 1 factorial. Sorry. Divided by 3 to the n plus 1. Reciprocal. 3 to the n over n factorial. Now you have to carefully simplify it. Okay, let's simplify it first. Then we simplify it. Okay. So we are told when we simplify it, you see this is 3 to the n. But this is 3 to the n plus 1. If you simplify by 3 to the n, the leftover would be 3. Okay, then you take care of those factorial. Let's write it down so far. So that give you x minus 4. The limit of. On the top, we have n plus 1 factorial. Down the bottom, we get 3n factorial. The top one, you simply should know that n plus 1 factorial would be everything up to the n plus 1. So you can think about it as x minus 4. That would be the limit of. We write this one as n factorial times n plus 1. Because it's going to be 1, 2, 3 up to the n. Then you pass the n to get to the n plus 1. And this is going to be 3n factorial. So that will help us. That will help us, you see, to simplify this one. You see, n factorial would cancel out. So that gives you absolute value of x minus 4. You see x minus 4, and that would be the limit of n plus 1 divided by 3 when n goes to infinity. So that would be a special case. You see, because this is just a 3, a number. When n goes to infinity, this would be infinity. You see, this would be infinity, and you are going to have an absolute value of x minus 4 times infinity. So in this case, depends on what you are going to be happening in this one. Because if it's going to be just a fixed number, if it's going to be a fixed number, 5, 6, 7, when you multiply by infinity, you see it's like, it's not correct to write it down, but I do. You see this is going to be like this. When it's going to be like this, you just put a question mark and then you have to argue that how we're going to get this one. You see, in this case, if your x, if this is going to be a number other than 0, you see, if it's going to be 5, 6, 7, the result would be infinity. And if it's going to be infinity, L is infinity. Infinity is bigger than 1. So your series is going to be what? Your series is going to be divergent. But the only case is that if this is, let's break it. So we break it in 2 parts. The first part is if this x is not equal to 4. If x is not equal to 4, 5, 6, 7, 2, 1. If x is not going to be equal to 4, so this is going to be a non-zero number. So 5, 6, 7. If you multiply by infinity, that would be infinity. You see, that's going to be the case. But if x happen to be equal to 4, see, if x happen to be equal to 4, this would be 0. 0 times infinity, that you cannot talk about it. But just go back to see what would happen if x equal to 4. You see, if x equal to 4, this would be 0. So you're going to have a 0 series, if you like. 0, 0, 0, 0, 0, 0. So 0, 0, 0, 0, end up with a 0 here. End up with a 0. Okay? So what's going to be your situation? Your situation is going to be that if it's going to be infinity, infinity is bigger than 1. So your series, you see this part over here, your series would be divergent. The only convergence that you can get is the bottom one. So this means the series, the power series, the power series is convergent only when x is equal to 4. You see, there's not going to be any interval because it's convergent only at one point. Okay, so it's very special one that you have to know it. So what's going to be the conclusion that we talk about it? In this case, we usually, you see, the conclusion is that if it's going to be only convergent at this point, we are going to say that the radius of convergent, the radius convergent is going to be equal to the 0. And the interval of convergent, there is not going to be any interval. It's going to be just 1 point, one number. So this is going to be the domain of the convergence or the interval of the convergence. Okay, it's very a special case. So we should be ready for it. So now if it's going to be given to be able to argue it for us, okay? So nicely you have to explain it. The difficulty is that this would be infinity. If this is going to be infinity, you know that the power series depends on x. X is a number. You have to avoid the 0 here. So you know that this would be 0 if x is 4. So we say that if x is not equal to 4, if x is not equal to 4, this would be a number 5, 6, 7. When you multiply by infinity, the result would be infinity. Infinity is bigger than 1. And by the ratio test, if the result is bigger than 1, the set is divergent. But if x is equal to 4, if it's x equal to 4, we just don't move. You see, we go back to the beginning. If x is equal to 4, we get 0, 0, 0, 0, 0, 0. So everything would be 0. So when everything is 0, it's convergent because the sum of the series is zeros. So that's why in this case, we get the divergent, and the other case, we get the convergent. So this means this power series is convergent only at one point. Remember, we have 3 cases for the power series to be convergent. At one point, the one with the radius convergent, and forever. This is at one point. That point is x equal to 4. So when it's going to be just convergent at one point, there is no radius. The radius is 0. The center is like you have a circle. You have a circle with a radius. When there is no radius, we get only the center, x equal to 4. So the radius would be 0. Interval, there is no interval, just one number. Okay, so be aware of these special cases if it arises. Okay, so that's important about this one. So that give you, we should have another case. Maybe the next one would give us that case too. So that's a number part C. So that's part D. As you can see, these problems of the power series are very rich. You learn quite a lot, and you should be ready for, not to be surprised if you get it. Let's see if the next one would give us the other possibilities. The next one is this series. You want to check the power series of sigma of. This is sigma of -1 to the n, -1 to the n, x to the n, divided by 3 to the n times n plus 1, n plus 1, and from 0 to infinity. Okay, let's check this one to see if there is anything special about this one too. They are the VIPs, if you like. Okay, let's check. So what's going to be the limit of the absolute value of an plus 1 over n goes to infinity. Again, check the powers of the x. So this time x to the n plus 1 on the top, x to the n on the bottom. They simplify it. There's the leftover is going to be x. You pull out the x. That gives absolute value of x. Okay, so this is going to be absolute value of x, and the leftover is going to be limit of n goes to infinity. This -1 would disappear because of the absolute value. So n plus 1 replace everything by n plus 1. So on the top, we get this one, 1. This is going to be 3 to the n plus 1. Then you replace the n by n plus 1, so that n plus 1 would be n plus 2. The bottom one, the same thing, an, it's going to be 1 over 3 to the n plus 1. Okay, for the top, you replace the n by n plus 1. For the bottom one, you just write it as is. Now, write the first one, use the reciprocal of the other one. So it's going to be the absolute value of x. You have the limit of n goes to infinity. The top one would be 1 over 3 to the n plus 1 times it by n plus 2. The reciprocal of the bottom means you get 3 to the n times n plus 1 on the top divided by 1. Carefully simplify. This 3 to the n would be out. 3 to the n out. We get the 3 here. So what's going to be the leftover? It's going to be the absolute value of x. Now we have the limit. Okay, the limit, the top, you get n plus 1 on the top. The bottom one, we get 3 times n plus 2 when n goes to infinity. Okay, again, you know, the degrees are the same. If you shrink it, it's going to be absolute value of x, the leading term on the top n, down the bottom 3n, n goes to infinity, so that gives 1/3. Absolute value of x times 1/3. So we are going to have 1/3 of the absolute value of x this time. Okay, this is your L. You know that. If it's going to be less than 1, then your set is going to be convergent. So you let it to be less than 1, and then you have to solve for the absolute value all the time. You solve for the absolute value to that give you what? That give you the radius of convergence. So this is it. So we are going to claim that. We have to explain it as we did for the other one. We say, okay, there you are. So the power series, the power series is convergent. Is going to be convergent if whatever you have, 1/3 of the absolute value of x is going to be less than 1. You force it to be less than 1. Then you have to solve for the absolute value because you need a radius of convergence. So you multiply by 3. So that gives you absolute value of x less than 3. This number is going to be radius of convergence. Okay, according to our definition, remember, if the absolute value of x is less than r, the series is convergent. So the conclusion is, so far is going to be your radius of convergence would be 3. You open it up, you get the temporary interval of the convergence. R is equal to 3, and the series converges. And the series converges. The series converges when your x is going to be between 3 and the -3. You open up the x. So again, you have to check the end point. You check to see if your series is also convergent at x equal to -3 or 3, because you want to identify the interval of convergence, okay? Because in the case of the ratio test will tell you only if L is less than 1, it's convergent. If it's greater than 1, it's divergent, but nothing about if equal to. So we check the equality. So you check x equal to -3, and you're checking x equal to 3. So we have to go back to the original series and do the checking. So x equal to -3 into the original series. Remember, this is the original one. And we replace the x by -3. We simplify to see if we get something extra. Okay, so going back, checking. So it's going to be the resulted series. The result series would be sigma r. Okay, so on the top, we did have the -1 to the n, x to the n, x is -3, -3 to the n. The bottom one, the same things, 3 to the n, n plus 1. You have to carefully simplify it. I'm going to simplify it. You have to take care of this negative sign here. negative 3 to the n would be negative 1 to the n, 3 to the n. So it's going to be equal to sigma of negative 1 to the n already, but you get another negative 1 here. Negative 1 to the n, 3 to the n. Okay, and the bottom one would be 3 to the n times n plus 1. Okay, you pull out this negative sign. Now we get the chance to simplify. These two would cancel out. How about these two? You see, negative 1 to the n, negative 1 to the n. We have a common base. So it's going to be negative 1 to the, you add these together, n plus 1, which is a 2n. So it's going to be equal to sigma of negative 1 to the 2n over n plus 1. But negative 1 to the 2n, 2n is an even number. 2, 4, 6, 8. And negative 1 to the any even power would be positive 1. So the result is going to be, so it's going to be equal to the sigma of. Now the top would be 1 because the power is even over n plus 1. You know that this is like sigma of 1 over n. So this series is like, if you shrink it, it's like sigma 1 over n. And you know that this is harmonic series. And harmonic series is divergent. Or is a p series. So is a p series. Is a p series or harmonic series? Divergent p series, okay? P series with p equal to 1. And it diverges. It diverges. You know that p series convergent if p is bigger than 1. So for x equal to negative 3, we're not going to get anything. So we get a divergence in this case. Okay, but we are not done. We have one more to check. We have to check x equal to 3. So go back to the series again. And instead of the, you see x to the n, it's going to be 3 to the n now. So we're checking x equal to 3. To check x equal to 3, so that gives us sigma of, that would be negative 1 to the n. This time it's going to be 3 to the n. And this is 3 to the n times n plus 1. Now 3 to the n and 3 to the n would cancel out. So it's going to be the leftover. The leftover is going to be sigma of negative 1 to the n over n plus 1. You see that would be positive, negative is alternating series. Is alternating series, the Bn is 1 over n plus 1. It's alternating harmonic series, in fact. So it's going to be, you see the Bn is 1 over n plus 1. So the limit of the Bn is 0 and the Bn is decreasing. You know, you can shrink it. You can say that this is like a sigma of negative 1 to the n over n. And we know this series is convergent. Okay, so is a convergent alternating series. Alternating series. So at x equal to 3, your series is convergent. Okay, you must be very careful that you don't miss any sign. Is negative 1 to the n, you see that's very crucial, these two together. But for one of them, you know, that negative 1 would disappear because negative 1 to the 2n is an even number. But over here is not. So you keep it, you get alternating series, and that's why you get convergent. So what's going to be the conclusion? The conclusion is the radius of convergent is 3. That's the radius of convergent. Interval of convergent, it was between negative 3 and 3. So it's a negative 3 and 3. And the point at negative 3, it's divergent. So it's a parenthesis. At positive 3 is convergent, is a bracket. So that gives you the, you know, that gives you the interval of convergence. Very nice problems to get through it. Okay. So the two cases, We have another series, a couple of more. I do this to get to the ABC again, because I just show you that this is the same thing that we repeated. Okay, so two problems from this number 4 on the test. Two power series, one with the, it's going to be powers of the x, okay, x to the n. The other one is the power of something else. And for the rest of the course, you see, these would be given to you. If you want to do anything with the power series, you have to know where this series is convergent. Okay, so I do the second list of this number 4. Okay, intentionally I call it A, B, C again. You know that these are going to be just two types, okay, for you to practice. So we continue again, we get to the A back. This is again the you know, it's A, I didn't change it. So the second A, if you like. So the second A is a nice series. These are from various, okay, questions that I gave on the test. So I want to get the idea of how you prepare for the test. X plus 8 over n, n 6 to the n. That's interesting. Seems to be complicated, but it's not. Be patient and nicely do the job. Everything would be fine. Okay, you want to answer the same question for this one. The radius of convergence. This series is about, you see, it's in terms of powers of x plus 8. So we should end up with the absolute value of x plus 8 less than something. Okay, so let's try. Let's get the, again, that ratio. So this is going to be the limit of absolute value of an plus 1, an, n goes to infinity. Okay, so this is going to be again equal to the limit of, I'm sorry, you know, I can simplify it. This is going to be x plus 8 to the n plus 1 over x plus 8 to the n. That's the way I write it down. You can write everything, you know, but you pull out the x plus 8. That's easier, but you can write the full details if you like. N goes to infinity. Negative 1 will disappear. So I need n plus 1. I change everything else, the leftover to the n plus 1. So on the top, I've already taken care of the x plus 8. So this is going to be 1. This n would be n plus 1. This 6 to the n would be 6 to the n plus 1. Down the bottom, it's everything is n. So we repeat that one, but for n 6 to the n. Okay, I usually take care of that x plus 8 first and then the rest. Write the first one, multiply by the reciprocal is going to be x plus 8. Okay, the limit of n goes to infinity. Bearing the top is going to be 1, n plus 1. And it's going to be 6 to the n plus 1. The reciprocal is going to be n, 6 to the n, 1. Simplify 6 to the n out, 6 to the n plus 1 would be 6. So the leftover is going to be absolute value of x plus 8 outside. And this would be the limit of n goes to infinity. On the top, get n. Down the bottom, we get 6 times n plus 1. You get the limit, you see, shrink this one, the top, the leading term is n. This would be 6 times n. So it's going to be the same as the absolute value of x plus 8. The limit of n on the top, 6n at the bottom. So n and n would cancel out. You get 1, 6. So it's going to be absolute value of x plus 8 times 1, 6. So it's like the absolute value of x plus 8 divided by 6. So that's eventually your limit of the absolute value of a plus 1 over an, the result. Okay, that's L in the case of the ratio test. Again, you know that you force it to be less than 1. Because if L is less than 1, the series is convergent. Okay, so you have to explain that the series, the power series converges if the absolute value of x plus 8 over 6 is less than 1. Solve for the absolute value, means you multiply by 6. So that gives you absolute value of 8 less than 6. When you less than 6, this means the ratio of convergence, because this series is about x plus 8, or in terms of powers of x plus 8. So, this is it. The radius of convergence is 6. And you open it up to get the interval. And the series converges when or on x plus 8 between 6 and negative 6. You have to subtract the 8. So that gives x less than 6 minus 8 greater than negative 6 minus 8. So that gives you a negative 14x, and that gives you a negative 2. You see? So far, this is going to be your interval of convergence. So you are going to be between negative 14 and the negative 2. But you have to check to see if you can add the endpoint. Can you add x equal to the negative 12, negative 14, or negative 2 to your interval of convergence? Okay, so as usual, we have to check the endpoint. Check for x equal to the negative 14 and x equal to the negative 2. So patiently, you have to go back to the series and substitute these two numbers to see what type of series are going to be resulted from. Okay, or are going to get, is it a convergent series or is it divergent? Okay, this is the original series. So I'm going to check the negative 14 first. Negative 14 for the x. Okay. So let's check x equal to negative 14. Substitute carefully. So there you are. We have the sigma of negative 1 to the n minus 1. On the top, you have x plus 8. So the x is negative 14. Negative 14 plus 8. Okay, everything to the n. Divided by n, 6 to the n. Simplify the top. Negative 14 plus 8 would be negative 6. So that would be a sigma of negative 1 to the n minus 1. So the top would be a negative 6 to the n. Divided by n, 6 to the n. As usual, you pull out this negative out. See negative 1 to the n, 6 to the n. So it's going to be equal to sigma of negative 1 to the n minus 1. At the top is going to be negative 1 to the n, 6 to the n, and then we get the n, 6 to the n. Okay, that gives you the chance to simplify. You see this would be simplified. But you have a negative 1 to the n, as we did it before. Negative 1 to the n minus 1. Negative 1 to the n. You add the power n minus 1, and n would be 2n minus 1. So it's going to be equal to sigma of negative 1 to the 2n minus 1 on the top, and on the bottom n. Okay, but negative 1 to the 2n minus 1 is an odd number. Since an odd number, negative 1 to the raise it to any odd power would be a negative 1. So that would be sigma of, okay, the top would be negative 1. Negative 1 over n. So you can pull out that negative sign. So it's going to be equal to negative sigma of 1 over n. You know that this is harmonic series, is divergent. So is a divergent P series. good. Okay, so we check x equal to negative 14, we didn't get anywhere. Okay, because when you substitute, be careful, this is very important here. Just pay attention to the negative 1 to the n minus 1, negative 1 to the n. So the power would be 2n minus 1, which is an odd number. So a negative sign to the odd would be negative. So that's why we get a divergent. Now we have to continue checking x equal to negative 2. Okay, so I'm going to substitute x equal to negative 2 in this one. That would make it to the positive 6. And then that would be simplify and give you a harmonic series, give you an alternating series this time. Okay, so we continue. X equal to negative 2 into the original series. So our series would be sigma r. We already got the negative 1 to the n. Okay, negative 1 to the n minus 1. So on the top, we put the negative 2 plus 8, everything to the n. And that would be n 6 to the n. So we simplify the top. So this is going to be sigma of negative 1 to the n minus 1. And that gives you 6 to the n. And this is n 6 to the n. Okay, now 6 to the n and 6 to the n would cancel out. You see that negative 1 would stay, and that would be helpful because that gives you an alternating series. Negative 1 to the n minus 1, okay, over n from 1 to infinity. Again, you know that it's a positive, negative. It's alternating harmonic series, which is convergent. And we accept that when you say it's convergent. So it's a convergent. It is a convergent alternating series. Alternating series. That's it. So for the endpoints, we did get the negative 2 convergent, but the negative 14 is not. So what's going to be the conclusion? The conclusion is that the radius convergent, you see, that's what we have here. Look at this one. So the radius of convergence is 6. But interval of convergence is going to be between negative 14 and negative 2. At negative 14, it's divergent. You have to use parentheses. As a negative 2 is convergent, you have to use a bracket. Okay, so R is going to be, what's that? R is equal to the 6. R is 6, and interval of convergence is a negative 14 and negative 2, open, close. That give you the result. As you can see, all of them are almost like each other. But you have to be patient, step by step, and just put them together. Okay, so that's A and the second part. Yeah, there are 2 more after. These are that was the type that it's x plus 8 or centered at anything other than 0. But the other 2 that are centered at 0. So let's check those. Just make sure that you know it. So we go with the part B, new part B. And we check this series. Probably this would be a special case. N factorial, 2 to the n, x to the n from 0 to infinity. Let's see what is special about this one. It's in terms of the powers of the x. So we'll end up with the absolute value of x to be less than something. That gives you radius of convergence. Okay, that's the difference. So let's try. Limit of the absolute value of an plus 1 over an. Okay, n goes to infinity. So this is going to be equal to the, you see, this would be x to the n plus 1 divided by x to the n. So the leftover is x, so the absolute value of x out. And then we have what? We have the limit of, on the top, you replace the n by n plus 1. So you get n plus 1 factorial divided by 2 to the n plus 1, divided by an, so everything would be n factorial, 2 to the n goes to infinity. So, I just form an plus 1 over an. For the x is easy, x to the n plus 1 over x to the n. So the leftover is going to be x, but this you just do a little bit of algebra to get it. So rewrite it, it's going to be absolute value of x, limit of n goes to infinity. So that would be n plus 1 factorial. That's a 2 to n plus 1. Use the reciprocal for the bottom one. It's a 2 to the n over n factorial. Simplify it. 2 to the n would be out. And that would be 2. So you are going to have the absolute value of x. Okay, the limit of. On the top, the leftover is n plus 1 factorial. Down the bottom is 2n factorial. N goes to infinity. You simplify it, remember n plus 1 factorial is 1 times 2, 3, n plus 1. So we can break it. It's going to be absolute value of x, or you can list the numbers and you simplify. So this is going to be n factorial, 1 times through n, times it by n plus 1. And this is 2n factorial. N goes to infinity. You see n factorial and n factorial cancel out. Yes, that's a special case. It's going to be absolute value of x. And then we get the limit of n plus 1 over 2. N goes to infinity. See, when n goes to infinity, this would be infinity because you have only n on the top. So we get the absolute value of x times infinity. So you have to break it in 2 parts as we did it for the other ones. Depends on x. If x is not 0, you see, because you let the inside to be 0, the inside would be absolute value would be 0 if x is 0. If x is not equal to the 0, this would be a number times infinity. The result would be infinity. You see, this is a special case. So this would be infinity if x is not equal to the 0. And if it's going to be infinity, infinity is bigger than 1. So the series would be divergent because the L would be bigger than 1. But as we talk about for the other one, if x is equal to the 0. If x is equal to the 0, you see, your series would be 0. Because your series is the powers of the x. You see 0, 0, 0, 0, 0, 0. So everything would be 0. And your series would be convergent. Okay, but you are going to have a convergent series at one point only. And that's the special case that I talk about it. So you've got to be careful for this one. Okay, so you explain that the series, the power series. Okay, the power series converges only at x equal to the 0, at one point only. So we talk about it. So the radius of convergence would be 0. And interval of convergence is not interval, it's just 1 point, 0. So that's, now I give you the other one. And the other problem that we did, you see this is, look at this one. That has happened when, it's not going to be powers of the x, it was something else. The same thing, but inside the absolute value was 4, so you get the convergence only at x equal to 4. But this new one is in terms of the powers of the x. So the absolute value would be 0 when x is equal to the 0. That's why we talk about this one around the 0, the other one around the 4. So it's the same thing. It can happen for either one. That your series would be convergent only at 1 point. If it's only 1 point, there is no radius. The radius is 0. And there is no interval because you have only 1 point. Okay, so that says, again, something special about this one. Okay, and let's check the last one, it's part C. It's in terms of the power of X, and it's going to be easy problem. So 2 problems, one in terms of the powers of the X, and the other one in terms of the powers of X minus 4, X plus 4 for the test. The rest are going to be the one like in your quiz. So you must know the integral test, okay, comparison test, limit comparison test. Should be able to check the series, alternating series, absolutely convergent, okay, as we did it for your practice quiz. So let's check this one, part C. The part C in this is the sigma of -1 to the n, okay, x to the n cubed. So n from 1 to infinity, this is the one that we have. This in terms of the powers of the X seems to be a straightforward one. So we check to see what type of series we have. So the solution is going to be, so again, we check the limit of an plus 1 over an, n goes to infinity. Okay, and this is going to be, it's in terms of the power of the X. So this would be x to the n plus 1. This would be x to the n. Simplify it. The leftover is going to be absolute value of x. So the limit of n goes to infinity. The absolute n -1 would be out because of the absolute value. The top is the leftover is going to be 1 over. You change the n into the n plus 1. So it's going to be 1 over n plus 1 all cubed. The bottom one would be just 1 over n cubed. Okay, you write the first one multiplied by the reciprocal of the other. Absolute value of x, limit of 1 over n plus 1 cubed times it by n cubed over 1, n goes to infinity. Okay, so going to be absolute value of x, limit of, the top would be n cubed. The bottom one is n plus 1 cubed. You see the leading term is going to be highest power of the x, going to be the same, highest power of the n. So absolute value of x, limit of n cubed on the top, n cubed on the bottom, n goes to infinity, so the limit would be 1 because you simplify it. So that gives absolute value of x. Okay, so you force it to be less than 1 to get the radius of convergent. Okay, so again, say that the power series. Okay, the power series converges when the absolute value of x is less than 1. It's already less than 1. You don't have to solve it for x like the other one that we did. So this means radius of convergent is 1. And the interval and the series converges. Okay, and the series converges when, see, that's going to be 1. Your absolute value of x less than 1, so you're going to have the x between -1 and 1. So temporarily, the interval of convergence is going to be -1 and 1. But we have to check the endpoints. We have to go back and replace x by -1 for x to see what type of series you have. And then you check the 1. Then you can decide what is going to be your interval of convergence, okay? So we have to check x equal to the -1 and x equal to the positive one. So let's checking x equal to the negative one. So we go to the series, replace x by -1. So what's going to be the series? It's going to be sigma r, -1 to the n. Okay, replace the x by -1, -1 to the n over n cubed. Now, -1 to the n and -1 to the n. You multiply the bases -1, you add the powers. So that gives sigma r, -1 to the 2n divided by n cubed. But the 2n is an even number. And a -1 to the power of the even number is going to be a positive one. So that would be equal to the sigma r. Okay, now the top would be 1. And the bottom one stay the same, n cubed. And you know that this is a P series. P series, P equal to 3 is convergent. So is a convergent P series. So we are fine for x equal to -1. We have one more number to check. We have to check x equal to 1. So how about x equal to 1? Go to the series. There you are. Substitute again. X equal to 1. So what we have is going to be sigma r, -1 to the n. This is going to be 1 to the n divided by n cubed. Okay, n from 1 to infinity. 1 to the n would be 1. So that would disappear. So this is going to be sigma r. This is a -1 to the n. This would be just 1, n cubed. So it's going to be sigma r, -1 to the n cubed. That's it. It's alternating series. You see p equal to 3. This series is, again, is convergent. Because even if you put the absolute value around it, that gives 1 over n cubed. Okay, so this is a convergent. Is a convergent P series. So at both endpoints, -1 and +1, you get a convergent series. So this means your interval would be a closed interval of a -1 and 1. Okay, so the conclusion would be, is that your radius of convergence is 1. Okay, radius of convergence is 1, and the interval of convergence, it was -1 and 1, but you close it. And that give you the interval. Very nice theories, okay, to get these numbers. Okay, that's it, the power series. It's very important, you know. I didn't want to rush it to give you another section before this test, but we do it because we have enough time. And then after your quiz, what we are going to do is, you see, when we say it's convergent, it's going to be convergent to a number. Since there's going to be an x and you converge it to the number, we call that number f of x. And then we introduce a function. So we say a function represented by a power series. Then we check whether this function will be differentiable, integrable, and we're going to have such a nice application of the power series for this course. That would be the best part of your course for the final. Okay, so that's it. So study that practice test that we have. The rest is just exactly the one that we did for the practice quiz. I'll have a look quickly at your quiz to see what's going on. And then I post a solution to that quiz for you so that you have everything available. So you'll be able, you know, to take your test. So the test is going to be similar to your quiz plus 2 questions from the power series. Okay, just let me know if you need anything. Otherwise, we are going to see you on Tuesday, 6:30. Don't be late, okay? If it's going to be some of, you know, a couple of you just, you know, come late 30 minutes, 10 minutes, something would be okay. but not something like 30 minutes. Okay. So I check the quiz. If it's going to be, if it's needed, I may post something else for you. Okay. But I have to check it to see how you're doing it, so that you know that you are not going to lose any point on the test. Okay. Take care and see you on Tuesday. Bye-bye.